Okay, we'll continue with example 4. And you're saying, well, what is so different with that example? What you're about to see. So we'll find the solutions to the homogeneous equation first. So y sub c. And then we should try e to the rt, or x, right, as usual. And then if you plug it in to this thingy, y double prime minus 4y is equal to 0, then here you will get, what am I doing? R square e to the rx minus 4 e to the rx is equal to 0. Eh? So e to the rx times r plus 2 and then r minus 2 is equal to 0. Eh? So what we get here is r is equal to plus or minus 2. So our y sub c is equal to c1 e to the 2x, negative 2x plus 2x plus combination of the two. Right? So we got that much. Now we're going to try for the particular solution, and we have this kind of thing. Right? So what we can do is we can try the particular solution combination of these guys, right? Once you have this, then you can have, well, what will give us derivative of this? I mean, if you take a derivative, second derivative, it has to give us something like this. And then the idea is, of course, e to the x times some kind of constant ax plus b. Because if you keep taking a derivative, product rules, so x might survive, and then constant, all of that. Okay, but what about this? Well, cosine and sine. So we should have, we already used the a and b, so c cosine 2x plus d sine 2x. All of it. Then you're thinking, that's a lot of work. Now, isn't it? And that's going to be complicated to take second derivative of this and plug it into our differential equation. So what I propose instead is, since this is linear equation, we can do these two separately, and it'll just work out. We can just add solutions. We learned that through experience. So why don't I just save this for later and just work on this? Okay, watch this. So y prime with still product rule, so it's e to the x times ax plus b, and then the derivative of the second one, so e to the x, and then we just have a, right? I'm gonna move it around a little bit and put a, squeeze a in the front, right here. Okay, and then if I take a second derivative of that thing, so I will have e to the x, ax plus b, and then I will have second one, which is same thing as this, and add it to this. Is that too much? Or you got this? You got this? Questions? Okay, now we plug it in to this differential equation. Y double prime minus 4y is equal to, here we have these two terms, but we are just doing this one at the moment. You know what I'm saying? So x e to the x. You get it? And then we'll do that part separately. So once I plug it in, y double prime goes in here. So we have e to the x. Why don't I distribute it now? It's okay. Ax, I think we have enough algebra in our algebra skills to do this. 2a e to the x, and then second part, e to the a plus bx, right? I'm gonna put them here, I guess. And I have to multiply by 4, so negative minus 4 e to the x ax plus b. And that whole thing needs to be equal to x e to the x. How's that? Good? Okay, now let's combine the like terms. So I have e to the ax here, and then minus 4 e to the ax here. So what I have is negative 3 a e to the x. Good? And then what's left here is I have b e to the x, and I have negative 4b, so I have negative 3b, and then here's 2a. So what I have is 2a minus 3b, and then e to the x. That needs to be x e to the x, eh? So yes. Okay, that tells you negative 3a is equal to this thingy, 1. Now, if a is equal, and then what we have is 2a minus 3b is equal to 0. Now, so here a is equal to negative 1/3, and then plug that in here. Too much algebra. So if I do it in my head, I'm pretty sure you can pull that off, right? Very good. So that particular solution y happens to be e to the x times a, which is this, negative 1/3 x, and then plus b. Good? Good so far? Now, what we are going to do is, I'm going to push this thing down. What we are going to do is the second equation, which was that thingy, cosine 2x, okay? So what we are going to do is y double prime of minus 4y is equal to cosine of 2x, is what we are going to solve here. So this one I'm going to try, y particular is equal to, we already used, so c, a and b, so cosine 2x plus d sine 2x. Good. And then y prime is equal to, can I just skip to the second derivative? I think we have enough skills to do this, right? Right? Derivative. So you will pick up negative 4c cosine 2x minus 4d sine 2x, because we don't even need the single prime. You know what I'm saying? Is that too much derivative, or are you with me? And then plug it in here. So what we have is negative 4. Ooh, no, very good. I thought I screwed up. Okay, negative 4 c cosine 2x minus 4d sine 2x. This comes from this y double prime part, and this one I just multiply negative 4 again. And this needs to be cosine 2x. Good. So what we have is combine the like term, negative 8c cosine 2x minus 8d sine 2x is equal to cosine 2x. Good. So that tells you c is equal to negative 1/8 and d is equal to 0. How about that? So y particular in this case is negative 1/8 of cosine 2x. And that was kind of obvious now, wasn't it? Take a two derivative and yeah. Okay, so all together now. What we have is dy is originally from the top one, which is c1 e to the 2x plus c2 e to the negative 2x, and then the second one e to the x and negative 1/3 x minus 2/9, and the last one, this one, is minus 1/8 of cosine of 2x. How about that? Good, we just add them up. Any questions? Okay, we'll take this example then. Okay, this one, I did this part yesterday, but I will do it again. Okay, so first we will try to solve the homogeneous part, this part. Okay, so we're going to try, this is common solution, e to the rx. And then if I take second derivative, that becomes r squared e to the rx, right? Plug it in here, so I have r squared e to the rx plus e to the rx is equal to 0, factor e to the rx, r squared plus 1 is equal to 0. So first of it, so r is equal to plus or minus I. You with me? Okay, then long story short, our thingy is equal to a cosine x plus b sine x, right? I skipped a step. Instead of c1 e to the ix and e to the negative ix, Euler's formula. You want to see that again? Some of your facial expression looks a little lost. Put your hand if you want to see how that came about. Nah? Y'all with me? Okay then. Now, the particular solution now, which is this one, the right hand side one, this thingy right here. So now I want to solve y double prime plus y is equal to sine of x. Okay? Now here we run into a problem. So usually what we did was we tried this, y is equal to a cosine x plus b sine x, right? Except that's already here. You see the problem with that? Okay, first of all, a and b, that was a dumb idea, right? Because we already have a and b, so we'll use c and d. But still, they're exactly the same thing. It's a like term, right? So this is going to backfire on us because it'll just combine with that thing. So we have to remember when we had a double root in this thingy, what did we do? One of them was e to the x, e to the rx, and the other one was x times e to the rx, isn't it? So we deploy exactly the same tactic here. So this one, I need to multiply the whole thing by x. Who's confused about that part? I mean, it's going to work out because if we take a product rule and take a derivative, this will cancel. So then we take a derivative. This one I'm going to take my time. Oh, this is a particular solution. So I have c cosine x plus d sine x plus now x and then derivative of the second part, which is negative c sine x plus d cosine x. Good. And then I have to take another derivative. So this thing now becomes negative c sine x plus d cosine x. And this thingy, I just recycle my work. So I will have minus c sine x. So I cannot recycle. I just do it. Plus d cosine x for the derivative of first thing. Now the second part is plus x. And then we have negative c cosine x minus d cosine x. How's that? Good. Now we plug it into this thingy right here. Okay, so y double prime plus y is equal to sine x. Okay, if I do that, y double, let's just combine things together here, right? Okay, let's see what we got. These two, so -2, right? It's a like term, so I have -2 What am I doing? Did I screw up, or there's this cosine? No, I didn't screw up, right? So -2c sine of x. Good. This one and this one. And then plus 2d cosine of x. Okay? And then, let's see. We have to add this thingy to that thingy now, right? Are they the opposite thingies? Yeah, this is exactly opposite of that. So there's that. Everything else cancels then, huh? So the other side just becomes sine of x. How about that? That worked out nicely. Told you this is going to work. Then, so that tells you c is equal to -1/2 and d is equal to 0, eh? Okay, then, so our y particular solution is equal to -1/2. What? Oh, we had x, x. See, up here I had x. So I'm going to say x times -1/2 cosine of x. See, that turns out to satisfy this equation. So altogether, my final solution is your common solution, a cosine x plus b sine of x, and then minus 1/2 x cosine of x from this part right here. How's that? Good. Any questions?